Okay, much like in the picture of the ML6, sigma only, then we did pi only, then we combined sigma and pi. Let's do exactly the same treatment for tetrahedral ML4 compounds. So if you recall, the sigma only bonding picture in the ML4 picture in ligand field theory is that the ligand group orbitals that are over here have A1 plus T2 symmetry. And then those form sigma bonding and sigma antibonding interactions, taking advantage of the fact that you have d orbitals that have T2, ligand group orbitals that have T2 symmetry. But then remember, the complicating factor is that you also have T2 symmetry in the px, y, and z orbitals. So the challenge there is effectively you've got 3 sets of orbitals that you have to then construct 3 molecular orbitals. And remember, the net result of doing that is always the same. Is you're going to make sigma bonding and sigma anti-bonding, like I already said. But then in the mid-range energy, you're basically going to wind up effectively with non-bonding interactions. In this particular case, it's the T2 d orbitals that are non-bonding, and then the symmetry matches that are only possible in this particular case, even though they're non-bonding, you still get symmetry and energetic matching, which then basically tells you the stronger the ligand field, the larger the value of delta T is going to be. And therefore, the ligand field strength is going to affect this in exactly the same way as it affected the octahedral compounds, except that it's influencing the T2 orbital set exclusively in this case, and it's completely not interacting with the E set in any way, shape, or form. But the same idea goes: the stronger the ligand field, the more this delta T will increase. Okay, so then let's now put the pi bonding picture on top of this. So now in this point group, remember the pi bonding now comes from the E orbital set. So that's reverse of what happened in the octahedral case. But the point being is that you're simply going to make bonding and anti-bonding combinations. So there's the bonding and there's the anti-bonding combination with the E orbital set. And then the net result of that is that as a result of that, you create a pi bonding and then pi star anti-bonding. And notice what happens. You're driving up the energy of the EG orbital set when you have pi donor ligands. And remember, that's exactly the same picture that we had seen before. When you basically have a pi donor ligand like we do here, the pi donor ligand does exactly the same thing to a different set of orbitals. In this particular case, pi donors drive up the energy of the E set. And then you can imagine pi acceptors are going to actually drive it downwards and stabilize it. So in other words, the pi donor destabilizes E with respect to the sigma only picture, and that is what brings it up in energy. And then that decreases delta T. And the point being is that this has exactly the same ligand field effect, and the nature of the ligand has the same exact consequence to the MO picture in the tetrahedral point group as it does in the octahedral point group. It's just working on a different set of orbitals. Then if you go to the last picture of where we have pi acceptor, when you have pi acceptor ligands, what that's basically telling you again is that these now are empty, and they still will symmetry match with the d orbitals over here, and make bonding and anti-bonding combinations, but you can kind of see the net result of this is that forces down and stabilizes the E set with respect to the sigma only picture again. So pi accepting ligands are actually stabilizing the E orbital set, and it actually increases the value of delta T. So same thing goes. Pi acceptors stabilize the lower lying D orbital set in this particular case, and that really drives the same exact trends in ligand field splittings and in the spectrochemical series. So the strongest field ligands are still the strongest field, or I should say the strongest field ligands in the octahedral point group are still the strongest field ligands in the tetrahedral point group, and the weakest field ligands in the octahedral point group are still the same weakest field ligands in the tetrahedral point group. And then that transcends all of the other possible geometries you will ever encounter. And that is the end of my presentation, and I want to thank you again for your attention.